Welcome to class today, pre-calculus students, on Thursday, November 7th. Hope you guys are doing well and hope you're ready to learn some math today. Let me get my Mimeo pad turned on here real quick and let's get started. I've had some students tell me that there's been a really loud humming sound in the background, and I've heard that myself. I'm trying out a new set of headset microphone today, so hopefully the video will be better. Announcements: you will have a test on Monday. If you're not going to come, please let me know by Sunday. I would really appreciate that so I can make plans and know who's going to be here and who's not. If you still owe me stuff from the first quarter, please get it in. That's really important. Okay, please remember, I'm respecting the fact that you're homeschooled. You're welcome to get behind. You're welcome to switch the days around and work on weekends and not work on weekdays or whatever you want to do. But when Monday rolls around and you walk in my door on Monday, you will not be allowed to get credit for any more videos or homework that you watch in the future. So anything you're behind on, everything has to be caught up by Monday. And also, you're not going to tell me orally what you have done. You're going to hand me a sheet of paper with everything written on it, whether it be the integrity sheets that I gave you or ones that you draw up yourself. So please keep that in mind. And I'm being less tough than a normal high school would be. Normal high school, you have to do the homework every day, whether you had an away, football game, basketball, soccer, fine arts, whatever it is. And then lastly, don't forget your review sheet. The only way you'll get the 5 bonus points is if you've attempted every single problem on the review sheet, so you know right where your questions are. And you're welcome to come to class Monday with none of the review sheet done. That's fine. Just understand you will not get the 5 bonus points on your test. Okay? All right. Having said all of that, let's go ahead and get started. I have not tried to go slower on purpose to be nicer or easier on you guys. I've just felt like we have covered some math in which the problems take a good amount of time, and so because of that, I have been a little more conscious of teaching one day and giving homework the next day. We are going to look at some word problems today, and because of that, that's all we're going to do. I'm not going to really teach you how to do them. We're just going to work through them together, and you're going to learn as we go. And then at the end of the period today, I'm going to give you a review sheet. Now, you understand the review sheet. Well, first of all, you understand tomorrow there's no new video, just the review sheet. And you can work on the review sheet today, tomorrow, Saturday, Sunday. That's up to you. But I will give you the review sheet at the end of the class hour today. Okay? Let's go ahead and get started. Now, we're going to look at some word problems today from lesson 7.2. Okay, word problems from lesson 7.2. The date today is the 7th, 11/7. And then one more thing. Yesterday we learned how to, 2 days ago we learned how to solve triangles using law of cosines, and then we, watch the cell phone there, and then we applied it to some problems yesterday. And so today what we're going to do is we're going to learn to solve some word problems using law of cosines, okay? So to give you some closure, we're going to look at 6 problems for class today, and it will take a while, so don't think it'll be super fast. It'll take a while for us to do these, and then we'll look at the review sheet at the end of the hour, okay? Please turn in your books. Sorry for the yawn, I do apologize. Please turn your books to page 619, numbers 25 through 35. Page 619, numbers 25 through 35. Most of these you'll find pretty basic and simple. And some of these I think you'll find a little more difficult, okay? Page 619, 25 through 35 odd. I am going to go pretty fast, so be ready to pause the video and back it up if you need to. Okay, if you'll look in your book at number 25, I did not put the words in here for you, but I did put the pictures in here for you to see. A park ranger establishes an observation post from which to watch for poachers. Having lost her map, the ranger does have a compass and a rangefinder. She observes some poachers, and the rangefinder indicates they are 500 feet from her position, and thus you see the 500 right here. 500. Let me change colors of ink so you can see it a little easier. There's the 500 right there. And you can't see the poachers. I cut that out of the picture, but they're over here behind some bushes. They are headed toward big game that she knows to be 370 feet from her position. So here's the 375, and there's the animals right over here, and there's the ranger. And then it says, using her compass, she finds the poachers I'm not sure how to pronounce this word, azimuth. It's the direction measured as an angle from north is 355 degrees, and that of the big game is 42 degrees. What is the distance between the poachers and the game? Now, I'm 99.9% sure they have a typo right here in the picture, and I'm going to tell you why I'm saying that. I solved the problem the way I think this should be drawn, and it really does make sense if you'll just watch for a second. If they are saying that from here to here is 355 degrees, that really doesn't make any sense, because if you then add from here to here 42 more degrees, you're going to get way over 360 degrees for the wraparound all the way. So like I said, I'm about 100% sure they wanted to start right here on the dotted line and circle around like that and stop at this line right here. Okay, so 355 degrees. So let me go over that again for you. And in fact, I'm sure that's what they meant, because it says in the problem the direction measured as an angle from the north. And so this line right here, this circle right here, should have started right here at the dotted line and came around and circled around and stopped right here at this dark bold black line right here, and that's 355 degrees. Now think about that for a second, students. If that's 355 degrees, then that means this angle right here, follow my line down, I'm going down the dotted line and then I'm going down the dark line. See that real skinny angle right there? I'm going to put an arrow in it right here. That real skinny angle right there. Well, that's 5 degrees. It has to be, students. If we start here and we circle around 355 degrees, there's only 5 degrees left. 5 degrees left that we can slip in this little area right here. So I have a question for you. See if this makes sense, okay? If from this dotted line over is 42, and if this little space right here is 5 degrees, then wouldn't the whole angle from this black bold line to this black bold, wouldn't that whole angle right there be 47 degrees? Because we know from here to here is 42 and this little bit is 5, so from this dark line all the way over has to be 47 degrees. So with that in mind, and I hope that makes sense. Now the question was, by the way, the question was, what is the distance between the poachers and the game? Well, here's the poachers right here, here's the game right here, so we're trying to find that distance right there. Now I've done this before with you guys. What I like to do is is to trace the triangle and get it off of the picture. So there's the triangle. Now it's not perfect, but you get the idea. So there's the triangle right there, and I'm going to tilt it just a little so it looks like the one there in the picture. Okay, there we go. Now remember, we already said this whole angle right here is 42 plus 5, so this is 47 degrees, and then this is 500 feet right here, and this is 375 feet right here, and we're going to call this x. We're looking for x. Now please watch this carefully. Please watch this carefully. Remember how we've done side angle side before? Whatever this angle is here, cosine of 47 degrees, then the side opposite is what always goes. In other words, if this is A, this is a little a over here. So whatever this angle is here, the opposite side, in this case, which is x, that goes right here on the other side of the equal sign, and then the other numbers go right here. So we have 500 squared plus 375 squared minus 2, 500, I'm running out of room, and then 375. So what I've taught you to do is to type this whole thing into your calculator. 500 squared plus 375 squared minus 2 times 500 times 375 times cosine of 47. And if you do that, I've already done that for you to save time, you'll get 134,875.615. And now take the square root of x squared so that we have x all by itself. And if you take the square root of one side, you must take the square root of the other side. You will get 367, which is the correct answer. Now let's see, was that in feet, miles? What was that? It was in feet, so this would also be in feet. So the poachers were right here, and the big game animals were right here. So the distance from the poachers to the animals is 365 feet. Let me get a drink of water here. Okay, 365 feet. All right, let's take a look at number 27. This one's really easy here. I could read the whole problem to you, but they give you a really good picture of it. And they're basically saying you have a trail, two streets intersect. I mean, they give you all these words, but they give you the picture right here for you, which I'm not a fan of. And on a test or a quiz, I'm not so sure how many I'm going to give you with pictures like this. I think that makes it really easy. We'll see. But they give you the picture right here, and if you read the whole problem, they explain everything to you. At the very end, it says, how far did she skate from A to B? So they're looking for this distance right here from A over to B. So the whole word problem can be summed up in, we're looking for that distance right there. So first of all, I'm going to trace the triangle like I always try to do off of this picture. And then let's go ahead and move this picture down out of the way a little bit. Okay, so there's the triangle without any distractions. So this is 110 degrees right here. This is 0.5 miles. This is 1.3 miles. And this is our x. Now remember, the last problem is just like this one, okay? I mean, we know that if we're looking for this side right here, x squared equals, then whatever angle's across from it way over here, that's what we're going to take the cosine of 110 degrees of, okay? And then I would have the other two sides, 0.5 squared plus 1.3 squared minus 2.5, 1.3, and then cosine of 110. Now let me grab my answer sheet real quick here. I've worked this out already. If you type all of this in your calculator right here on the right hand side, which is what you're supposed to do, you will get 2.384626186. And then you take the square root of both sides to see what x equals, and you'll get approximately 1.5. Don't forget, these numbers up here were in miles, so 1.5 would be in miles. So do you see what we're doing today, students? We're learning how to use the law of cosines to solve word problems. Very interesting. It makes you think. Well, it's good for you. And and just shows how practical this can be. All right, let's take a look at number 29. Number 29 is not really hard, it's just long, okay? If you'll read 29 on your own, at the end it tells you got a group of college students, they're navigating, and then it says in the end, calculate the angles for each one of these. So we're going to have to find this angle, and this angle. Now we know all three sides, 1, 2, 3. Now what I did to make this problem a little easier, eventually we're going to have to use some of these numbers squared just by the formula. So I went ahead and I'm going to write this off to the side to help you. 45.2 squared equals 2043.04, and then 31.6 squared. We're going to use these numbers later, so I'm just writing them off to the side so you can see it. 31.6 squared is 998.56, and then 22.4 squared equals 501.76. So we're going to use that a little later to save time. Okay, well, in my notes, I solved for angle S first. No certain reason at all. So if I'm solving for angle S right there, then that means I'm going to have cosine of S. Now, if I'm going to have cosine of S, the side opposite S is 45.2. So I'm going to go way over here, and I'm going to put S squared. And then equals, of course, then the other two sides would be T and U. So it would be T squared plus U squared minus 2TU. All right, so S squared would be 45.2, so I'm going to go ahead and put 2043.04. T squared, that would be 22.4 squared, so 501.76, plus U squared, that would be 31.6 squared, that would be 998.56. And then minus 2 times T times U, or in other words, 2 times 22.4 times 31.6 gives you a negative 1,400, and let me look at my notes here, 1,415.68 cosine of S. Okay, and then of course this is all one term right here, so leave those together. Okay, but we need to bring this number over and this number over and change their signs. So if you bring them over and change their signs and combine, what you're going to get is 542.72 equals negative 1415.68 cosine of s. Now we're going to divide both sides by negative 1415.68, and if we do that correctly, we'll get negative 0.3833 equals cosine of s. Now we're looking for an angle, so you have to hit second cosine and then this number right here, and you should get 113 degrees equals s. I'm going to come up here, and for angle s, I'm going to put 113 degrees. All right, and there's probably a little better color I could probably use there to stick out a little better. 113 degrees. All right, let's go ahead and let's solve for another angle. We could either do T or U. I'm going to go with what I have in my notes, and I solve for U next. So since I solve for U, that means I'm going to have cosine of angle U. So if I have angle U, then way over here I will have U squared. And then of course the other two sides would be S squared plus T squared minus 2ST. Now, U squared would be 998.56. S squared would be 2043.04 plus T squared would be 5,000 or 501.76, and then 2 times S times T would be negative 2024.96 cosine U. All right, and then we bring this number over, we bring this number over, we change their signs, make them both negative, and if we do all that correctly, we end up with negative 1,546. And by the way, I've checked all of these answers in the back of the book just so you know, so these are accurate, equals negative 2,024.96 cosine U. All right, and now divide both sides by negative 2,024.96, and you will get a positive 0.7635 equals cosine of U. Now you're looking for an angle, so we got to use second cosine and then type in this number, and you will get 40 degrees for angle U. 40 degrees for angle U. So angle U is 40. And then obviously it's really easy to find that last angle. Just add these two together, you get 153, which would leave 27 degrees for angle T. There we are. Moving on to number 31. Now number 31 is probably the toughest problem on here in my opinion. And so let me grab a drink of water here. And let's see if we can't figure this out. Okay, I'm going to use a bunch of different colors, so be ready for that. Okay, let's go ahead and draw a coordinate plane because it says we're dealing with two airplanes that are taking off. So, and we learned how to do this some months back, how to draw these. Okay, so let's go with airplane number 1 will be in red, all right, and then airplane number 2 will be in blue. Alright, so here we go. Let's start off with red. If you read the word problem carefully, two airplanes leave the airport at the same time. The first one flies at a speed of 150 kilometers per hour at a direction of 320 degrees. So the first airplane is red, so I'm going to draw it in red. It went 320 degrees, so we go 90, and then 180, and then 270, and then 50 more degrees would be 320 degrees. So there's the first airplane right here. All right. There's the first airplane. Okay, now in blue, let me go ahead and get this up here in blue. The second airplane flew at a angle of 200 degrees. So see if this makes sense. Watch. I'm going to go 90, 180, and then 20 degrees more. Okay, 20 degrees more, and then draw my line. Now, let's see. First of all, let's see if we can't get some distances here. Okay, the first airplane in red, if you'll look at your book, it says it was flying at 150 kilometers per hour. And look at the last sentence. After 3 hours, how far apart were the planes? So we know the plane took off here and traveled to this point here. And we know it did it for 3 hours, so 150 kilometers per hour times 3, we know the length it's traveled is 450 kilometers. Now the other airplane is traveling at a speed of 200 kilometers per hour, so 200 times 3, the length this airplane, or the distance this airplane has traveled and now is right there, is going to be 600 kilometers, because 200 times 3. So that should make sense. Now the question is this. Are you ready for the question? The question is, how far apart are the two planes? How far apart are the two planes? So if here's one plane, and here's the other plane right here, and I want to find out their distance, that would definitely not be one way to do it, but see if we can't change this a little bit. There we go. So we're going to find the distance between these two airplanes. So here's one airplane right here. Here's the other one. And we're going to find this distance. See how we did that? Now, I've got to find this angle inside the triangle. Well, let's see if we can do that, okay? Follow the red line. We know we went 90, 180, 270, and then 50 more for 320. So from here to here, we know that's 50 degrees. Okay? Now, the blue airplane went 180 plus 20 more for a total of 200. So if that's 20, we know from here to here, that's got to be 70 degrees, right? Because 70 plus 20 gives me 90, and this whole quadrant here has to be 90 degrees. So think about it. If from here to here is 20, and it is, because I went 90, 180 plus 20 more is 200. So if from here to here is 20, then from here to here has to be 70. So it looks like the whole angle is going to be 50 plus 70. From here to here is 50, and from here to here is 70. So the whole angle inside this triangle right here is going to be 120 degrees. So 120 degrees. So what I would like to do now is get rid of all the distractions, okay? So I'm going to take my pen here, and I'm going to quickly try to trace over that triangle, and then get it out of the way just a little bit here, if we can. Sometimes it's hard to do. Didn't want to do that, that's for sure. Okay, there we go. Now, students, please watch this carefully. You should have all that stuff in your notes still. I know the triangle was rotated just a little bit like that. Now, here's what we should have then. Right here we said what, 120 degrees, I believe. And here I think we said 450. Then over here I think we had a length of 600. So students, you really should be able to see this pretty well. It once again just comes down to the law of cosines. I mean, we're trying to find this missing side right here across from 120 degrees. So it really should not be too difficult to do. My missing side here is x. So I'm going to put x squared equals, then my other two sides would be 450 squared plus 600 squared minus 2 times 450 times 600 times cosine of 120. There we go. Law of cosines. Now if you do that correctly, x squared would equal, let me look at my notes here very quickly, x squared would equal exactly, it's kind of funny, 832,500 no rounding at all, and then take the square root of both sides. And if you round, you'll get 912 kilometers. 912. So you know how far apart the two airplanes were. Pretty cool problem. All right, number 33. Number 33 says the longer base of an isosceles trapezoid measures 14 feet. Now let's stop right there. Let's get an isosceles trapezoid up here, okay? That's an isosceles trapezoid. Well, not really. It's not perfect because the right side and the left side are supposed to be congruent, and the top and the bottom are supposed to be parallel. All right, so it says the longer base is 14, so this would be 14 right here, and the non-parallel sides are 10 feet, so this would be 10 feet and this would be 10 feet, and then the base angle measures 80, so this would be 80 and this would be 80. In an isosceles trapezoid, base angles are congruent, okay? They are congruent. Find the length of a diagonal. So we're going to draw a diagonal here. Here's my diagonal. It goes from here up to there. All right? And very quickly we'll fix this. All right, we're going to find the length of that diagonal. Now, come on guys, look at this. If I could take my white pen out real quick and just delete some stuff. Look. If I just got rid of this right here, got rid of that and got rid of that, look students, I'm left with a triangle. And here's my diagonal right here. My diagonal is right here. There's my diagonal right there. And that's what I'm going to find the length of. So I don't have a right triangle, but I don't need one. I have an oblique triangle. I'm going to call this X, and look what I've got. Side angle side. So here we go. Law of cosines again. X squared equals 14 squared plus 10 squared minus 2 times 14 times 10. And then cosine of 80 degrees. Now, if you'll type that whole thing into your calculator correctly, that whole right side, let me look at my notes, I've already done that, you will get, sorry for the delay here, you will get 297, so x squared will equal 297.3785103, and then take the square root of both sides and you'll get 15.7. So there, you found the length of the diagonal, 15.7. Now, I am not scared to tackle question B. Question B says find the area. The area of a trapezoid, by the way, I believe is height times base 1, base 2, all of that divided by 2. Or some of you probably learned it as 1/2 height parentheses base 1 plus base 2. But I'm not going to go through that. We're going to skip part B. Finding the area would simply mean this. It would mean we'd have to find the height, which we could do pretty easily. We'd have to draw a dotted line up and down like this. And then notice we have a right triangle right over here. And we have, here's my right triangle right here. There, there, and there. There's my right triangle. And so with that, I could then say, okay, here's 80. I have opposite and hypotenuse, so I could say sine of 80 equals opposite over hypotenuse, and then find the height. That'd be my height right there. And then I have to find the base. I have to find this base up here, because notice the formula says base 1 plus base 2. So 14 is one base. You have to find that base and then find the area. It'll be a very, very lengthy problem. I don't think it's hard. I think it's just really, really long. So we're going to skip that, and we're going to go on to our last problem. And this one's actually looks really complex, and it's actually one of the easiest ones we're going to do. Okay, 3 circles are arranged shown below. Find the length of PQ. So here's P going down to Q. That's the line they want us to find, that real dark black line there. They want us to find the length of PQ. Now, if you'll think about it, it's really, really serious. I mean, it's really, really simple. I mean, a circle always has the same radius. If the distance from here to here is 1.8, then that means any radius you draw is going to be 1.8. That makes sense, right? I mean, if this dot's in the center of the circle like it's supposed to be, then any radius you draw is going to be the same. So I have a question for you. What's the distance from here to here. Wouldn't it be 1.8? That's a radius. And then look, do you see how the radius of this circle from here to here is 1.4? So what's the distance then from here to here? Wouldn't that also be a radius of this circle, 1.4? And how about from here to here? Wouldn't that also be 1.4? Sure it would be. And look at this radius here. See this dotted line? It's 1.1. So the distance from here to here is 1.1. Do you see that? So watch this very carefully. Let me see if I can trace over this triangle. Not bad. Now I'm going to pull this out of the way. And there's my numbers right there. So if from here to here is 1.8 and from here to here is 1.4, then the total distance right here would be 3.2, correct? Sure it would be. And if I have from here to here is 1.4, from here to here is 1.1, add those together, and the whole distance right here would be 2.5. And then I think I should have brought back, I wonder if there's any way to bring back that picture. There is an angle right here, 109 degrees, and I should have wrote that down. So we know the angle here is 109, and we know this side is 3.2, and this side here is 2.5, and they want us to find this length here. Well, it's law of cosines again. So x squared equals, and then one of the other sides is 3.2, and one of the other sides is 2.5, and then minus 2 times 3.2 times 2.5, and then cosine, and if this is x here, then the opposite angle from x is 109 degrees. And there we go. If you type that whole thing into your calculator, you will come up with x squared equals 21.6990947. Take the square root of both sides, and you'll get 4.7. So there we go, 4.7. So what we have done here is found this length right here. So I know it's not been super long, I get that, but guys, it's very important. I mean, I could teach you, I could have given you some examples out of the book and then gave you homework, but I try to keep it short whenever possible. That's very important to me, that I be as short-winded as possible and let you work, and learn these by practice. Now, let me reach over. You guys know usually I have everything typed up here, and I'm surprised I forgot to do this, but I guess old age is setting in, but I forgot to type the review sheet. So here's the review sheet now that you guys need to be working on. Page 594, number 61 through 68, and also page 670, numbers 7 through 16, all. And of course this one up here was all also. So now I'm not sure how many problems it is. Probably one of the smallest review sheets you've had in a long time. We've not covered an extreme amount of math. But this does cover all of the problems that will be on the test. So we're looking at 8 problems, 7 through 16, and I'm really having a hard time believing that's accurate. And again, my reputation will stand strong. You guys know I'm always organized and have this stuff written down, but I'm just not convinced that's it. So hold on one second while I kind of check this out. 670, 7 through 16. Yep, that covers law of sines, law of cosines, and word problems, so that's good. And then page 594, number 61 through 68. 61 through 68. Yep, trig equations. Well, men, all that I can say is this, is I'm kind of laughing. Don't get used to this. You know that by now. So 8 problems here plus 10 problems. So a review sheet that usually has 40-some problems, you have 18 problems. So, boy, I don't see there being much of an excuse why your review sheet will not be done by Monday, but that's between you and your parents and all that. So there's your review sheet that will cover the entire test, which will be given to you on Monday. Please do these problems. Tomorrow's video will just be me working these problems out, and call or email if you have any questions. I hope you guys have a very good day, and I look forward to seeing you on Monday.